Part 3, transformation. So for transformation today, you will see that we'll talk about rotation, reflection, and translation. So rotation meaning you have one pivot point, okay? That's like a circle, and you rotate whatever shape that you have, clockwise or counterclockwise. That's rotation. There's always a center point. Reflection is like a symmetry, that you have a line, and if these two things are going to be exactly the same on each side, and you can actually fold using the center line and make them overlap with each other perfectly. That center line is called the mirror line. And translation, basically you move this whole thing without changing the orientation, only horizontally, vertically, left or right, without any rotation. That's translation. When the transformation is done in a coordinate system, it is called a coordinate system transformation. So we talk about the three types, and in the following, we'll talk about some examples. Okay, here we want to give some examples. Simple coordinate system transformation. We'll assume there's a point with coordinate x0, y0, and we want to find the image of this point under reflections. In the x-axis, okay, A, if we have x, y, any number, say x0, y0, with respect to x-axis, we draw a perpendicular line to x. This height is y0. And on the other side, we want to find exactly the same height. And this point would be same distance to the mirror line, exactly the same distance. And therefore, x0 remain unchanged. Y0 need to go down to 0 and go one other negative y0 to get to the mirror point. So this length has to be perpendicular to the mirror line and equal to the other side. And part B is similar to this, but now the mirror line, instead of x-axis, is y-axis, x0, y0. Same way, you draw a perpendicular line to the mirror line, and this distance is x0. You need to find the same distance on the other side, that is another x0, to find the mirror point for x0, y0. Okay, in this case, x0 first go back to 0, and then go back to another negative x0, because it's going smaller. So minus x0 and y0 would be the mirror point for x0, y0. So we just have to remember that. For mirror line, that is x-axis, x doesn't change sign, y changes sign. For y-axis as the mirror line, the y doesn't change, x changes value, because you can see that you're coming from one side of the x-axis to the other side with respect to 0, okay? So part C. In the line x equal to a. What is x equal to a? So say here is a. X can only equal to a regardless of what y is. Y can be any value, but x will always equal to a. So that's a vertical line on this coordinate system, okay? Say you have any point x0, y0 here. We draw a perpendicular line to the mirror line. What's the distance of here? That is x0 minus a, okay? We need to find the same distance on the other side. Here is another x0 minus a. What is the position for this point? This point, x0 has to retract x minus a and another x minus a. So this point, x-axis wise, is x0 minus a minus x0 minus a. Twice, okay? You first go to the mirror line and another point. And if you solve this, that will be 2a minus x0. That's the x-axis. And the y is just y0. Y doesn't change value. Okay? So remember, if you have any point either on this side or that side, to find the other symmetry point with respect to x equal to a is this. Or you can always do is draw a line and do the perpendicular line to the mirror line and find out the distance, and then find out the distance on the other side and add or subtract to the original x value depending on which side you are on. Okay, D is similar to C. That is, now instead of a vertical line, you have a horizontal line. Y equal to A. Y can only be A regardless of the value for x. X can be anything, but Y can only be A. So that's a horizontal line. And if you have, say, any number that is x0, y0, you need to find out the mirror point. We do a perpendicular line. What's the distance of this line? That is y0 minus a. Then we go to the other side. We need exactly the same distance on the other side here. And what's the coordinate point for this one? X doesn't change value. And the y is y0 minus double the distance. That is just like what we did before. 2a minus y0. 2a minus y0. That would be the symmetry point for x0, y0, respect to y equal to a. Okay, the next two examples are relatively complicated. What is y equal to x or y equal to negative x? E and F, I'm going to put them together. X equal to y is a very important line. That is a line that goes through 0, has a 45-degree angle with respect to either axis, okay? And in this case, x equal to 0, y equal to 0, they always are equal. Why they are equal? Because this is a 45-degree angle. This is a right angle, and this is a 45 as well. So this right angle triangle is an isosceles triangle. So this side equals this side. So x always equal to y. The y equal to negative x line is the opposite one, going through the second and the fourth quadrant. Okay, so usually we call this one the first quadrant. This is the second, this is the third, and that's the fourth. They are all different. For the first quadrant, x greater than 0, y greater than 0. Second quadrant, x negative than 0, y greater than 0. For third quadrant, both are negative. For the fourth, x positive, y negative. Okay. For second and fourth, you can see that y and x and y, they're always opposite. Y greater than 0, x negative than 0. So this line is also a 45-degree line. On this line, x and y are always opposite in sign. You can see that in this problem, to find the symmetry point of any point is relatively complicated. If you have x0, y0 right here, again, you do the same. You do a perpendicular line, and you find out the distance. You find a distance on the other side. This would be the symmetry point of x0 and y0. So, okay, for x0, y0, we find out the symmetry point is right here. What is this point? So let's draw two lines. Let's do a different color. Okay. This distance equal to this distance, and that's both a right angle triangle. So these two triangles are the same. Okay, then let's look at this triangle and this triangle. And because this is a 45-degree line, this part equals to this part. And the closer two are the same. Therefore, the outer two are the same as well, right? The total of the two triangles, they're exactly the same. And inside these two are the same. So therefore, this triangle and this triangle are the same. So for this triangle, because this is x0, y0, therefore the distance here is x0, and the distance here is y0. Therefore, this distance is y0, and this is x0. For the symmetry point now, x equals to y0 now, and y-axis equals to x0. They actually reverse. So in this case, looking at coordinate system, how do we find x, y, the position of any point? You look for the perpendicular line of that point onto x-axis, and the distance to 0, that's the x. For y, you do a perpendicular line to the y-axis, and this distance is the y. So for this point, this triangle gives you this y0 as the x position and x0 as the y position. It's a little confusing. The distance on x-axis is x coordinate. Distance on y-axis is the y coordinate. For y equal to negative x, it's a different scenario. You will find that because the negative sign, both are changing. You have x0, y0 on this side, and again, you do a perpendicular line. You will find this number is, because the negative sign is negative y0 and negative x0. Practice problem 15. What is the y coordinate of the image when point 5, 3 is reflected over the line y equal to x? So we've seen just now that if you want to find x0, y0 with respect to y equal to x, then we just reverse the sign, reverse x and y, right? So this mirror point would just be 3, 5. Reverse the position for x and y. Practice problem 16. The points 2, 3, and 5, 1 are reflected over the x-axis. Find the number of square units in the area of the quadrilateral whose vertices are the points of their images. Okay, reflected over the x-axis, you have 5, 1 here, 2, 3 here. The reverse side for the first point would be 5 doesn't change, y becomes negative, and this is the point. And this point would be x remain the same, and y becomes negative. Okay, in this case, we can find the area. This is a trapezoid. We know that the trapezoid has top A, bottom B, height h. The area would be 1/2 top plus bottom multiply h, right? For this shape, the top is 2 units. The bottom is 1, 2, 3, 4, 5, 6. In reverse sign, this is 3, so double that. That's 6. Multiply the height. Height is going from this side to this side. That's a 3. So you can use this to find out the answer. Practice problem 17. Square ABCD. Let's draw this ABCD. And we want to rotate 90-degree clockwise. So clockwise, rotate this way. Now, the square is ADCB. And reflected over a diagonal line. That is this way. So flip. So now B is here, D is here. AC is on the diagonal line, so they don't change position. Lower left and upper right. The square is then reflected over a horizontal line through the center. Now the horizontal line through the center. So you're gonna top becomes bottom, bottom becomes top. So now B is here, C is here, A and D. What point now corresponds to the position originally occupied by B? Originally occupied by B is here, now is D.